Welcome to Neuraxon's Amplitude Normalization tutorial. In this video, we're going to cover a few different topics. The first set of topics is how to apply amplitude normalization methods in both real-time and post-hoc situations. And we'll also discuss the various normalization options available in the MR software. So to get started here, I'm in the home screen of my software, and I'm going to start by editing the settings of an existing protocol I've already created called two-channel EMG. So I'm going to go to my settings, which brings us to our measurement configuration here. We can see that I have two EMG channels enabled. One is going on the left rectus femoris, and one is going on the right rectus femoris, which we can see here indicated on our muscle map on the left. And I'm going to go to my online processing tools to apply the real-time normalization. And this is also where I can apply any additional real-time processing that I'm interested in. So generally, we're going to use amplitude normalization when performing a maximum voluntary contraction, or MVC. And that MVC is typically held for 3 to 5 seconds. It's an isometric contraction. There are lots of different MVC test positions available for different muscle groups. In this case, we're going to be performing the MVC with manual resistance applied from the leg, trying to do a leg extension as hard as possible for 3 to 5 seconds. So I'm going to build my real-time processing pipeline here by adding in my amplitude normalization method. And we have a few different characteristics here that we can edit. The first characteristic is the window length. For example, a shorter window may ensure a more stable reference value. A longer window might filter out more unwanted noise. It's generally going to be between 500 to 1,000 milliseconds. I'm going to choose 500 in this case. The second characteristic we can edit is the amplitude, which is the y-axis zoom level or visual display range. The default is 120%. A percentage of 120 is going to allow any EMG activity that exceeds 100% of the normalized value to be seen. So it's common for rapid or forceful dynamic contractions to elicit more EMG activation than most isometric activities, which is generally the type of activity we're performing with the MVC. So because I want to be able to see all values that might go above that reference value, I'm going to keep this to the default of 120. And while I'm here, I'm also going to add smoothing to my signal processing pipeline. I'm going to smooth my signal so that it is rectified with an RMS algorithm, and I'm smoothing out any big spikes as well. So I'm going to go ahead and choose 50 milliseconds here. So once I'm happy with this processing pipeline, I can press OK to save changes and move to my green action button, Measure, to begin the measurement. So to record the MVC before we record any test activity, we're going to start by hitting the Make MVC button. So I'm going to go ahead and hit that MVC button. The first thing we're going to do is a quality check. So I can see with no movement, the baseline EMG activity is low. I can activate my left rectus femoris and my right rectus femoris, and I can see that activity come in through the graphs. I can also show raw signals. This is going to show me the raw EMG without that smoothing applied. So you can see what that looks like. And then as soon as I'm ready to record that MVC, I'm going to hit the record button. So since I have two different muscles, I'm going to perform the MVC on both of those muscles in the same exact recording, but I'm going to do them in sequence, so one right after the other. So once I hit record, I'm going to perform that 3 to 5 second maximum voluntary contraction on the left side. When doing MVCs for multiple muscles in the same measurement, you can always pause in between to change the test position if desired. Whenever you're ready to continue, you can go ahead and just hit the continue button. And now I'm going to perform that same 3 to 5 second isometric contraction on my right side. All right, perfect. So now we are ready to stop, and we can see when we're saving data, the recording is automatically saved as an MVC file, so with MVC in parentheses at the end of it. In order to apply the peak values detected in this MVC file to any subsequent test activities, we're going to choose the Save and Measure Again option. So we can see here that it's telling us the MVC stack was updated, and the y-axis has changed to a percentage value, automatically normalizing to those reference values detected in the first measurement. So I don't want to make MVC again. I already did that. This time I'm going to choose Activate. So now we're ready to record. Whenever I'm ready to record that test activity, I can simply hit the record button, and I'm going to perform just a few leg extensions on either side. And you can see we're getting up to values of about 50%, sometimes over 50% of that MVC detected. So we'll do a few on the right side here, and then stop the measurement. So now we can either continue to record more activities by hitting Save and Measure Again. All of those activities will be normalized by that first MVC we measured, or we can hit Save and View to allow us to view and further process that data or run a report. Before saving, I'm just going to go ahead and rename my recording with the name of the muscles in question. Save and View is going to take me to the View tab up at the top in our workflow here. So now let's talk a little bit about adding amplitude normalization in post-processing. This particular record doesn't need any more normalization. It's already been processed, it's already been normalized, but for the purposes of this tutorial, I'm going to open up my signal processing operations and just delete or remove all processing that has already been added. So we can see in the background here, this is just our raw signal. So now the signal processing menu looks a lot like the real-time signal processing menu that appeared in our measurement configuration. And I can apply any of those same operations. So I can go ahead and add amplitude normalization and any other operations that I want to include from the operations above. So now you'll see that we have more options available to us. We can either normalize to a manual value, which is going to prompt us to select a manual value in microvolts, a peak value, so that would be a peak value within this recording, the mean value within this recording for each muscle, an MVC stack, or values from another record. So if I wanted to normalize to the peak value, we'll see that we get to choose a window. So if I want to just go ahead and see what that peak value looks like, I can preview that, and I could see the peak EMG value detected within this 1000 millisecond green window here. So this is a situation where we can tell maybe that window is a little bit too big. We see we have a lot of low values and some high values near the middle, and we want to narrow into a little bit more of this high peak we see more so in the middle here. So if I go back to my settings, I can choose a window of maybe 500 milliseconds. Let's go ahead and preview that. Now this is going to give us a little bit more realistic of a result of that peak activity within that isometric contraction. Whatever window you choose, it's up to you. We recommend being consistent with it throughout your research. And the software makes it easy to understand exactly where that window is defined. So when I apply my processing, it's important to hit this clear processing first checkbox, so I'm not applying any additional processing over processing that has already been applied. In this case, we know we're starting with a raw signal, but this is just a good practice, and I can press OK. So now my signal in this particular record is normalized to a peak value within that same recording. And you could see what that peak value is in microvolts within these parentheses here. So the peak value detected is 57.6 microvolts on the left rectus femoris and 40.4 microvolts on the right rectus femoris muscle. I hope you found this tutorial helpful, and please let us know if you have any questions. Feel free to reach out to support@neuraxon.com.